The National Electrical Code (NEC) is the primary source of regulations for electrical installations. It provides guidelines for voltage designations, including markings for different voltage configurations. Section 110.14 of the NEC specifies the requirements for circuit markings, including voltage designations. It states that each circuit and branch circuit at its origin and at each outlet shall be legibly marked with its voltage and phase designation. The voltage marking shall include the voltage between conductors and, where applicable, the voltage to ground for grounded conductors. Table 110.14 in the NEC provides specific voltage designations for different types of circuits. The table shows the official voltage markings according to the NEC. Let's look at some examples. Firstly, for a circuit voltage of 120 volts to ground, the voltage marking is 120 volts. Secondly, for a circuit voltage of 208 volts to ground, the voltage marking is 208 volts. Thirdly, for a circuit voltage of 240 volts to neutral, the voltage marking is 240 volts. Fourthly, for a circuit voltage of 277 volts to ground, the voltage marking is 277 volts. Fifthly, for a circuit voltage of 480 volts to ground, the voltage marking is 480 volts. Sixthly, for a circuit voltage of 208/120 volts, the voltage marking is 208/120 volts. Seventhly, for a circuit voltage of 120/208 volts, the voltage marking is 120/208 volts. Finally, for a circuit voltage of 120/240 volts, the voltage marking is 120/240 volts. The voltage designation always refers to the voltage between conductors. For grounded systems, the voltage to ground is also included in the marking. The order of the voltages in a marking indicates the primary voltage and the secondary voltage, if applicable. When marking circuits, always refer to the most recent edition of the NEC and consult with a qualified electrician or electrical inspector to ensure compliance with all applicable regulations and safety standards. Correctly identifying voltage systems helps to ensure safety and proper operation of equipment. These standards are constantly evolving. Always stay up to date with local, state, and federal guidelines. Understanding the NEC requirements for voltage designations is crucial for safe and compliant electrical installations. Following these guidelines helps prevent electrical hazards and ensures the proper functioning of electrical systems. This information provides a foundation for understanding voltage designations as outlined in the NEC. Always consult the latest version of the NEC and qualified professionals for specific applications and interpretations. The NEC is updated regularly to reflect changes in technology and safety practices. Make sure to use the latest edition for all electrical work. The information presented here is for educational purposes and should not be considered a substitute for professional advice. Always prioritize safety when working with electrical systems. Proper voltage markings are essential for identifying the voltage level of electrical circuits and equipment. Accurate labeling is important. It helps prevent accidental contact with dangerous voltages, which can lead to electrical shock or electrocution. Proper voltage markings also prevent damage to electrical equipment. If equipment is connected to the wrong voltage, it can be damaged or destroyed. This can result in costly repairs or replacements. Voltage markings facilitate troubleshooting and maintenance. Where electrical problems occur, voltage markings can help electricians quickly identify the voltage level of the circuit or equipment involved. This can speed up the troubleshooting process and reduce downtime. Voltage markings are a critical component of electrical safety. They are required by the NEC and other electrical codes. It is important to understand the NEC requirements for voltage markings and to follow them carefully. The NEC provides specific requirements for the size, color, and location of voltage markings. These requirements are designed to ensure that voltage markings are easily visible and readable. The NEC also provides requirements for the information that must be included in voltage markings. This information typically includes the voltage level of the circuit or equipment, the phase designation, and the grounding configuration. Electrical systems can have various voltage configurations. This includes single-phase, three-phase, and direct current systems. Each configuration has its own unique voltage markings. It is important to understand the different voltage configurations and their corresponding markings. Single-phase systems typically have two conductors, a hot conductor and a neutral conductor. The voltage between the hot conductor and the neutral conductor is typically 120 volts or 240 volts. Three-phase systems typically have three hot conductors. The voltage between any two hot conductors is typically 208 volts, 240 volts, or 480 volts. Direct current systems have two conductors, a positive conductor and a negative conductor. The voltage between the positive conductor and the negative conductor can vary depending on the application. Grounding is an important safety feature in electrical systems. Grounding helps to protect people from electrical shock. Grounding also helps to protect electrical equipment from damage. Voltage markings should indicate whether a circuit or equipment is grounded. This information is important for ensuring that the electrical system is properly installed and maintained. In addition to the NEC, other electrical codes and standards may also provide requirements for voltage markings. These codes and standards may be specific to certain industries or applications. It is important to be familiar with all applicable electrical codes and standards. This ensures that voltage markings are properly installed and maintained. Voltage markings are an essential part of electrical safety. By understanding the NEC requirements for voltage markings and following them carefully, it is possible to create a safe and reliable electrical system. It's important to periodically inspect voltage markings. Over time, markings can become faded or damaged. Inspecting helps ensure that they are still legible and accurate. Damaged or illegible markings should be replaced immediately. Replacing ensures that electrical systems are properly identified and maintained. When making changes to an electrical system, be sure to update the voltage markings accordingly. Failure to update markings can create a safety hazard. Keeping markings up to date helps prevent confusion and ensures the safety of electrical workers and others. Voltage designations are not arbitrary, they follow a logical system rooted in electrical engineering principles. The voltage between conductors is a fundamental parameter. It determines the amount of electrical potential difference available to drive current through a load. In grounded systems, the voltage to ground is equally important. It represents the potential difference between any energized conductor and the earth. This value is crucial for safety as it dictates the risk of electric shock in case of accidental contact. The order of voltages in the designation, such as 120/240 volts, conveys information about the system's configuration. Typically, the first number represents the voltage to ground. The second number indicates the voltage between conductors. This distinction is vital for understanding how the system operates and for selecting appropriate equipment. Consider 120/240 volt single-phase system commonly found in residential settings. Here, 120 volts is the voltage from either hot leg to the neutral wire, while 240 volts is the voltage between the two hot legs. Appliances designed for 120 volts, such as lamps and small electronics, are connected between a hot leg and neutral. High-power appliances like electric ranges and dryers utilize the 240 volts. In a 208/120 volts three-phase system, often used in commercial buildings, 208 volts is the voltage between any two of the three hot legs, and 120 volts is the voltage from any hot leg to the neutral wire. This configuration provides both 120 volts for standard outlets and lighting and 208 volts for larger equipment like air conditioners and some machinery. Similarly, a 480/277 volt three-phase system is common in large industrial facilities. Here, 480 volts is the voltage between the hot legs, and 277 volts is the voltage from each hot leg to the neutral. This higher voltage level is suitable for powering large motors and other heavy-duty equipment. Understanding the different voltage designations is essential for electricians. Proper voltage designations ensures that they connect equipment to the correct voltage supply. Incorrect connections can lead to equipment damage, fire hazards, and electric shock. Electrical inspectors also rely on voltage designations to verify that electrical installations comply with the NEC and other applicable codes. Accurate markings enable inspectors to quickly identify potential safety hazards and ensure that the electrical system is installed correctly. Equipment manufacturers also use voltage designations. They ensure that their products are compatible with different electrical systems. Clear voltage markings on equipment help prevent misconnections and ensure proper operation. Proper training is essential for working with electrical systems. Electricians and other electrical workers should receive thorough training on voltage designations. They should know how to identify different voltage configurations. They should be able to interpret voltage markings. They should be able to connect equipment to the correct voltage supply. Safety is always the top priority when working with electricity. Always to energize circuits before working on them. Wear appropriate personal protective equipment. Follow all applicable safety procedures. The NEC is a comprehensive document. It covers a wide range of electrical topics. It is important to stay up to date with the latest edition of the NEC. Changes and updates occur regularly. The NEC is not just a set of rules, it is a living document. It reflects the latest advances in electrical technology and safety practices. Understanding the NEC is an ongoing process. It requires continuous learning and professional development. Voltage designations play a crucial role in electrical safety and proper equipment operation. By understanding the principles behind voltage designations and following the NEC guidelines, one can create safe and reliable electrical systems. The voltage designation is a critical piece of information on any electrical system. It tells you the voltage level that the system is designed to operate at. Using the correct voltage designation on electrical systems is important for several reasons. Firstly, it helps to prevent electrical hazards. Secondly, it helps to ensure that electrical equipment operates properly. Thirdly, it helps to make it easier to troubleshoot electrical problems. Firstly, to help prevent electrical hazards, using the correct voltage designation on electrical systems helps to prevent electrical hazards. If electrical equipment is connected to the wrong voltage, it can overheat, catch fire, or explode. Using the correct voltage designation helps to ensure that electrical equipment is connected to the correct voltage, which can help to prevent these hazards. Secondly, to ensure that electrical equipment operates properly, using the correct voltage designation on electrical systems helps to ensure that electrical equipment operates properly. If electrical equipment is connected to the wrong voltage, it may not operate properly. For example, a motor that is connected to the wrong voltage may not run at the correct speed, or it may overheat and burn out. Using the correct voltage designation helps to ensure that electrical equipment is connected to the correct voltage, which can help to ensure that it operates properly. Thirdly, to make it easier to troubleshoot electrical problems, using the correct voltage designation on electrical systems helps to make it easier to troubleshoot electrical problems. If electrical equipment is not operating properly, the voltage designation can help to identify the source of the problem. For example, if a motor is not running at the correct speed, the voltage designation can help to determine whether the motor is connected to the correct voltage. Using the correct voltage designation can help to speed up the troubleshooting process and make it easier to fix electrical problems. When selecting electrical equipment, it is important to make sure that the equipment is rated for the voltage of the electrical system. The voltage rating of the equipment should be clearly marked on the equipment. It is important to follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions will provide information on how to connect the equipment to the electrical system and how to operate the equipment safely. If you are not familiar with electrical work, it is important to hire a qualified electrician to do the work. A qualified electrician will be able to install electrical equipment safely and properly. In summary, Using the correct voltage designation on electrical systems is important for preventing electrical hazards, ensuring that electrical equipment operates properly, and making it easier to troubleshoot electrical problems. Always follow the manufacturer's instructions when installing electrical equipment, and hire a qualified electrician if you are not familiar with electrical work. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes.